Brings us to part F. What is the value of the Lagrange multiplier from part E? Now, in part E, we had our Lagrange multiplier. That's what these lambdas are referred to. The Lagrange multipliers are our lambda values. What are their values? So from equation 4, we could solve for what lambda is, or from equation 5. Either one of these would work to solve for what lambda is. So I'm going to take equation 4 here, and I'm going to pull that out. We're just going to plop it here. So now we have our equation for lambda, and we're going to solve for what lambda is. So lambda is going to be equal to our x1 value, 10 to the power of negative 0.5, times our x2 value, 5 to the power of 0.5. And what I get from my lambda value is 0.7071. Now, what happens in part G if our budget increases by $1? So what if our budget changes from $20 to $21? Our old budget was that $20 was greater than or equal to x1 plus 2x2. That was our old budget. Our new budget would be 21 would be less than or equal to x1 plus 2x2. So how would this affect our Lagrange equation? Our Lagrange equation before, in part E, we had this Lagrange equation. I'm just going to pull all of this content to reference. So let's look at what's going to change here. So here we had our old Lagrange equation. What value is going to be changing here? If our budget increases by 1, the 20 over here changes to 21. So this part becomes 21. We'll put our changes in red. Now, does the first derivative with respect to x1, does this change at all? No, it doesn't. Does our first derivative with respect to x2 change at all? Again, no, it doesn't. Does our derivative with respect to lambda change? Yes, this value here becomes 21. So let's look at the effects of this. In our previous solution, we used from equations 1 and equations 2. We determined this relationship here. We determined this relationship. We had not used equation 3 yet. So does this part change with our new budget? Does our relationship between x2 and x1 change? No, it doesn't. This part stays the same. What changes is as we substitute it into our third equation. So we would sub this into equation 3. We would get 21 minus x1 minus 2 times 0.5 x1 is equal to 0. We would have 2x1, sorry. 21 minus 2x1 is equal to 0. 21 would be equal to 2x1. x1 would be equal to 10.5. That would be our new value. And then we would get our new x2 value would be equal to 0.5 times 10.5. This would be 5.25. Our new x2 value. And then we would have our new maximum utility. So that would be 2 times 10.5 to the power of 0.5 times 5.25 to the power of 0.5. And that would give us 14.849. So this is our new Umax. Our old Umax was equal to 14.1421. The change in Umax is going to be our new minus our old. It's going to be 14.849 minus 14.142 our change is going to be 0.707. This is the value of our lambda. So what lambda tells us is if our budget increases by 1, how much our maximum utility would change. If our budget, that m value, increases by 1, our optimal value changes by lambda. So I showed you guys a full calculation. I could have bypassed all of that calculation and said, if budget changes from 20 to 21, U max will increase by, and I had calculated my lambda in part F, would increase by 0.707. U max, the new U max, would have been the old U max, 14.142 plus 0.707, which would have given me 14.849. So I would add it on.